Here are the commercial hand warmers we're going to study today. Bob and I are going to take a look at the insides of them here in a little bit because we've never looked inside of one before. Okay, welcome to another edition of Garage Science. Bob was getting kind of cold, so he said, why don't we do an experiment that involves another exothermic reaction? So I thought, why not take a look at hand warmers? All right, we use these to go when you go skiing, or if like me, you take them along when you go muzzleloader hunting because you're in the woods for hours and you're freezing to death and you don't see anything, so at least you want to be warm. So these are hot hands. We're going to take a look at them and actually take them apart and look at them here in a little bit. But these are the reactions we'll be looking at. Okay, so let's take a look at one first, and then we'll go back and we'll do the reactions to see what's really going on here. Okay, Bob and I are going to take a look inside of one of these hot hands things. Bob mentioned I should wear gloves because I'm not really sure what exactly is inside of these. We took one out a little bit ago, and we did exactly what they told us to do. We shook it up to activate it, and we're going to talk a little bit later about why that works, but it does feel nice and warm, so I'm going to give that one to Bob, and I'm going to take out another one. It says open here somewhere, but about half blind. All right, there we go. Take that out. Kept in a pouch. We're going to get all the chemicals to go that direction. You can hear them shaking around in there. Dump those puppies out. Oh, there we go. Look in there. Well, looks just like a bunch of black powder to me. No, wait, I see crystals. There's white crystals in there. And that's about it. It's just a nice grainy powder. All right. Well, let's go. Let's go back to the whiteboards and explain what actually is going on inside of this black powder with the little white crystals in it. All right. Here we go. So, we're back again. So what's really going on here inside these hot hands? Well, if you notice, here's the full equation. This is the lengthy one. The iron that's inside of these things, powdered iron, it's ground up so you get lots of surface area, is mixing with water vapor from the air plus oxygen. Because if you notice to begin with, they're kept sealed until you want them. That way the water can't get to them and the oxygen can't get to them. And what's happening here is it's turning into iron hydroxide, which is a base, plus heat. This breaks down, and what you end up with is the ferric oxide, like this. Now, the shorter version is this one now. Iron plus the oxygen. If you notice here, we have the iron and the oxygen, and we're skipping this intermediate step. We're going directly to the iron 3 oxide down here. Now, you should be able to balance this. In addition, if you look closely, you should recognize what kind of reactions these are also. An element plus a compound plus another element goes together to make a single compound. All three things going together to make one. And then that one, it seems to break down into two different compounds, breaking down. That compound, okay, down here, if you shorten version, you have just the element plus another element, no compounds involved, just two elements, making a complete compound. They're going together. You should be able to balance this, and remember, least common multiple will help you out. But what else is really going on here? And that's a good question. Just give me a second. Well, if it's just iron rusting, why can't we feel the heat from a nail rusting? It's the same reaction. It's like Bob had a question about his tool. Why can't he feel the heat coming up from his tool? Well, if it's rusting like that? Well, here's the answer. Well, part of the answer. Time. It's all about time. Even though this is an exothermic reaction, and you get the same amount of heat, regardless of how long the reaction takes, if you can shorten the reaction, you can get all the heat at once. And that's why we use sodium chloride. It's a catalyst. It speeds up the oxidation. It speeds up this process. Okay? The same process that happens, unfortunately, to our cars when they salt the roads in the wintertime to get rid of the ice and the snow. It gets on the bottom of our cars and helps the cars rust out faster. Same exact reaction. I wouldn't rush out and hug your car in the wintertime to think it's going to warm up anytime soon, but it's the same basic reaction. There's also other things. If you noticed, when we took apart the hand warmer, it looked very black. That's because of the carbon. The carbon is there to absorb oxygen from the air. That'll pull the oxygen in so you can get the oxygen for the iron to react to it. There's also vermiculite in there. Vermiculite is a kind of a puffy-like stuff that uses an insulation, and it's used in there for the same reason, to keep the heat in so it kind of stays warm for quite a while. There's also cellulose. That's plant fiber, and it's in there to do another thing. It's to absorb the water, because remember in the long reaction, one of the intermediate steps was water, and so if you absorb the water, then your hands don't get wet. Okay, so that's how the next time you're out sitting in a tree stand, freezing to death, with your little hand warmer trying to get warm, that's how it works. You have to remember all these nice reactions. Right there you go. All right, have a good day. Sorry, Bob. Holding a rusty wrench isn't going to keep you warm.